We're continuing with arithmetic sequences here. Let's get started. We're going to take a look first at a recursive formula for an arithmetic sequence. So a recursive formula, I can't remember what we've already covered here, if we've seen this previously. I think we had, but so for an arithmetic sequence here, a recursive formula is going to be one that is dependent on a previous iteration, where we're going to define it in terms of the iteration, the n that happened right before it. Now let's take a look. We'll discuss this here again in just a second. Now whenever we're looking at an arithmetic sequence, what we need to find is that difference between this iteration and the one before it. So we find that difference. We're going to take the -7 minus the one before it, and we find the difference between these two. Now we know it's arithmetic, so it'd be the same for all of them. We know our difference here is 11. Now, if we want to define this in a recursive formula that's dependent on the iteration that came right before, here's all we have to do. The next iteration, a sub n, is going to equal the previous one, n minus 1, plus that difference. If you took that number, add the 11, you always get our new number. Now, we have to define this here, that n has got to be greater than or equal to 2, because we are going to be building this. We need to know the previous iteration here. So we have to know the first one in order to be able to define this recursive formula. So all I'm saying here is that we have to call this for n greater than or equal to 2. We can't just say this is true all the time, because you wouldn't know what n sub 1 or n minus 1 would be. Okay, so let's play the game again. We're going to find the difference here, and we're going to do 37 minus the 25. I'm taking the second iteration minus the first, and I get 12. So a sub n is going to be a sub n minus 1. So we're doing this recursively, so the one previously, plus we add 12. Now it has to be true for n greater than or equal to 2, because we have to know the first iteration, or this formula is not going to work. All right, now an explicit formula is not going to be dependent on the previous iteration. It's going to be dependent on the first iteration here. We're going to need to know a1, but other than that, it isn't going to be building constantly off the previous iteration. So we've already seen this formula. We used this in our prior video. We're going to use it again here to make an explicit formula, not dependent on the previous iteration. So if we're going to find an explicit formula here, we always need to work on the difference because it's arithmetic. So we find the difference between this one, and we get 10. Okay, now let's find an explicit formula. It's based on the first iteration, but not the previous one. Not every single time are you building it off the one prior. Okay, so we know our formula here. A sub n is going to equal, this is a1, plus that difference times n minus 1. Now, this is what we were doing before. They have just tidied this up. Do you see what they've done is they've distributed the 10 here. So you've got 10n minus 10. That's how they changed it into this. It's the same thing. I don't really think it's necessary to tidy it up, but that's what they're doing here. All right, so let's try it ourselves. So we're going to have 47 minus 50, taking the second iteration minus the first, and we're going to get -3, and that's okay. Remember, we don't have any problem with that. It really is adding. You're adding a negative. You could think of it like that. Now we want an explicit, so this is going to be built on the first value. So there's a1. So this is my d. It's usually plus the d times n minus 1, but if it's plus -3, do you see what I've done here? Okay, now this is really true, but let's go ahead and do what they've been doing, where they have been tidying this up. And so this is going to I just distributed the -3. This is going to turn into 53 minus 3n. And there we go. Okay, yeah. So next up here, we're going to look at arithmetic sequences, but they're finite. So the sequence doesn't just go on indefinitely, where we're just generating number after number after number. So we're going to have a little twist here. We're going to do basically the same idea. So again, this one is finite. We know it's arithmetic. So we are going to look at the difference. We need to find d. So d is going to be the 1 minus the 8, just like we've been doing. Second iteration minus the first. So here's my difference. D is going to be -7. So let's use our explicit formula here. A sub n equals that initial Our first iteration is 8. So again, they're doing plus -7 and -1. So they're doing all the same things. So if we did this, we'd have 8 minus 7n plus 7 if you distributed it, and that's how they're getting down to 15 minus 7n. Okay, now this all looks exactly like we've already been doing. This is an explicit formula for this sequence, but here's what's different. This sequence is finite. And what we need to do is they're asking us to find the number of terms. In other words, how many iterations have there been? What is the value of n for that last term? So let's put the last term into our formula. -41 is our last term, equals 15 minus 7n. We want to know what iteration, what value of n is -41. Well, if we solve this, just do the basic algebra, solve this for n, we get 8. So -41 is the last number in this sequence, and it is the 8th number. It's n equals 8. So there must be 8 terms in this finite sequence. Okay, now pause it if you want to try this on your own, but I'll take you through here. So d is going to be the 11 minus the 6. So we get a difference of 5. So d is 5. Now let's just set up the sequence. So we've got, well, I'll just do the formula here, d and minus 1. Here's my explicit formula. So a sub n is going to be the first term plus 5 times n minus 1. I'm going to go ahead and just do what they've been doing to tidy it up here. I'm going to get 1 plus 5n. Okay, now that's my explicit formula, but that's not what they want to know. They want to know the number of terms in this sequence. And so what we're going to do is take that last term, the 56, and we're going to find out what number it is in the sequence. So I solve this, I'm going to get 55 equals 5n, n is going to be 11. So this sequence stops when it gets to 56. That's it, it's over. And we want to know what number that is in the sequence. It is the 11th number. All right, we're going to end here with a couple of application problems. So a child gets $1 a week in his allowance. They're going to increase it to $2 per week every year. So basically he's getting a bump of $2 every year. So yeah, I didn't like this one. Okay, so let me show you. So they're not, when we get to calculus, we'll often start a sequence with n being 0. And yet in this textbook so far, they've always started with n being 1. And so I think we need to be consistent with that. And they're actually not being consistent with it here, and they haven't ever talked to us about that. So we're going to set this up. We're going to make our formula here where we know that the increase is 2. So my difference is 2. He starts with $1 a week plus 2 times n minus 1. So I'm going to start this with, this is based on n equals 1, okay, which is how they've been doing it. And the formula they gave is not going to do that. So let's send this through here. Oops, that's not right. So I send that through, and so I get -1 plus 2n. Now this is based on n starting at the number 1. And again, if I show you what they did here, they started with n being 0, which is totally a legal thing to do, but they have not been doing it that way. Now here's why it matters. We want to know what the child's allowance will be when he's 16 years old. Okay, so here's our formula. Now, he is 5 years old to start with. We want to know what's going to happen when he's 16. Well, that is a difference of 11. But here's the trick. If n started with 0, then this difference, we want the 11th iteration, it's going to be n as 11. But when you start with n as 1, then he's going to be 16 when n is 12. So follow me here on this. Because we have 11 more, so our difference is 11, but our first one is the number 1. And so 11 more iterations after this is going to get us to n equals 12. So we want to know what is going to happen on the 12th iteration. So it matters whether you start with n as 0 or whether you start with n as 1. We're starting with n as 1. which means we need to add 11 iterations to this first one, which gets us to the 12th iteration. So we're looking for a sub 12 is when he'd be 16. It'd be negative 1 plus 2 times 12. It's going to get us 23. So his allowance will be $23 when he's 16. Okay. All right, so we're starting with, we're trying to get our formula here. So 10-minute runs with a difference of 4 each week. So my difference is 4. Here's my initial, 10, 4 each week. Now we're starting with n is 1 here. This is based on n being 1. So here's our formula. We could tidy that up. 10 plus 4n minus 4. What am I doing? A sub n. Okay, so there's our explicit formula. 6 plus 4n. All right, so we want to know how long her runs will be 8 weeks from today. I'm not 100% sure if they mean 8 weeks later. I'm assuming they're meaning 8 weeks later, so let's check this. Actually, let's see if they did it here. Yeah, I'm a little confused on what they're doing there. I'm not sure if they mean, if they do it from today, then that's going to be the 8th iteration. That's what the answer's got it as. So I don't know if they mean 8 iterations later. I think what they're saying is in week 8. Yeah, that's really confusing in the wording. I think they're saying in week 8. So we're looking for the 8th iteration. 6 plus 4 times 8. That's going to give me 32. Oh, sorry. This should be a 10. I was wondering what was going on. That should be a 10. This is going to be 32, 42. Okay, so as you can see here, there can be some confusion on what they mean by their iteration. I'm having a little trouble with what they're saying. I think what they're saying here is in the 8th week, it's iteration number 8. And we saw how important in the last one it was to be clear whether you're starting with n equals 1 or n equals 0. And we're going to say we're going to start with n equals 1 until we get to calculus. Okay, I hope that makes some sense. And I think that's the end of our discussion of arithmetic sequences for now, too.